All right, it's me, your host, back again. And when I left you last, we were in Chapter 1, the section entitled Extending the Notation. All right, and that's kind of important. It's going to be a little picky at first. It's going to be a little tedious at first, but we're going to be doing this all semester long, so it's not going to be something that we just introduce in one chapter and stop using. It's going to continue to be used throughout the semester. And let me show you. Remember I had written, oh there it is. Remember I had written y equals beta sub 0 plus beta sub 1 x, and now we can add on that stochastic error term, right? Here's the deal. There's only one beta sub 0. There's only one beta sub 1. We're going to be going about trying to estimate those. But there's a bunch of different y's. If this is the grade students made in a class, then there's an individual y for every student, pardon me, in class. I'll show you that in a second. And so what we want to do for those variables that are different for every, well, no, let me do this first, right? Here's a little example I put together, just a very short and simple one. Let's say you got 3 students. Pat, Chris, and Lynn. You're gonna run your regression. That's not a lot of data, but on those 3 students, right? So for Pat, the grade was 80 and the hours of study was 5. For Chris, the grade was 49 and the hours of study was 4. And for Lynn, the grade was 95 and the hours of study was 6. Well, that means there's more than one of these, right? So what we do is, and I'm going to draw this in horned frog purple to differentiate it. Subscript I, subscript I, subscript I. And looking back at that little table I just showed you, you notice I had I equals Pat, I equals Chris, I equals Lynn, all right? So we do that to remind ourselves, and it's going to be important. It's not just trying to follow some rule of hoop you have to jump through. We do that to remind ourselves there's more than one y. There's as many y's as there are observations. There's more than one x. There's as many x's as there are observations. There's more than one stochastic error term, because how far off it was for that student, it could be different for every student. Remember, that's how far this particular student varied from the very deterministic relationship here, that there's some random element. And how much each one varied is going to be a different number. By the way, presumably this number adds to 0. That on average, everyone does get the grade that is indicated right here. But that, yours might be 4 points higher, 4 points lower, whatever. Might not be exactly the stuff you studied, or it might be like, oh my God, this is the only thing I studied. And so your grade ends up being a little higher. Now, let me remind you of what this is talking about then. X, Y, beta sub 0, Y equals beta sub 0 plus beta sub 1, X. All right. Notice that there's only, I should do this too. Slope equals beta sub 1. Okay. How many beta sub 0s are there on the graph? Just the 1. How many beta sub 1s are there on the graph? Just the 1. How many y's are there? Oh, good Lord. They're all over the place, right? How many x's are there? All over the place, right? So we can have multiple x's and y's. And notice I didn't do the little subscript I over here. That's because we're not talking econometrics here. We're just drawing the equation of the line. You don't have to remember that. That's not important. If you put subscript i's on there to be careful, that would have been great. Wouldn't have taken off for that. But what I'm emphasizing here is that the things we subscripted with an I were things that we're going to have more than one number for that. See, do I want to show you that other bit there too right now? And let's say we got those 3 students. One of them might have been really and truly up there after they studied this much. So that gap right here from the green line to the red dot, oh good Lord, that's a terrible bracket. I was never good at art or really just writing legibly. My poor daughter Meg has inherited that from me. We'll call that stochastic error term sub 1 for student sub 1 who earned grade sub 1. And then maybe this other kid, let's see, I'll use a different color, purple. Maybe this other kid earned this grade. 2y sub 2. So their stochastic error term is that gap right there. It's how far below they were from the green line. So there's a whole bunch of different stochastic error terms. Well, I shouldn't say a whole bunch. As many as we have observations. As many y's as we have observations. As many x's as we have observations. But only one beta sub 0. Only one beta sub 1. So we don't put the little subscript I on those. It doesn't make sense. There's only one of them. Only one of them. As many as we have observations. As many as we have observations. As many as we have observations. Let's see. And I believe I extend this here for a moment. We're almost always going to, oh yeah, okay. All right. This means that, I just showed you that. Yeah, I just showed you that. All right. Oh, if it is truly random, then for an entire set of 1,000,000 students, it should sum to 0. That's right. Otherwise, it's not truly random. And here I am, by the way, in my notes here showing here I extended it a little bit, and what I did there was, there's Pat and Chris and Lynn, and I made up a specific relationship. Let me write that down on there because it was on the previous page. Oh, it was my 50 plus 4 hours of study. I don't have a pen here, do I? I have a pencil. Let's see. I should have put that right on top of this table. Grade equals 50 plus 4 times hours. Okay. Now again, we're talking here, trying to understand this stochastic error term. All right, so let's see. Focus in there. There you go. Let's say the relationship that we asked God about, and God said, well, it's 50 plus 4 times hours. So then Pat, all right, should have earned, let's see here, how many hours they study? 20, oh, they should have earned a 70. Oh, that's right. That's under expected grade. We expected Pat to earn a 70. Because Pat studied for 4 hours. 4 times 5 is 20, plus 50 is 70. We expected Chris to earn a 64. 4 4s are 16. Oh, good Lord, that should be 16. All right, 4 4s are 16 plus 50. Here, I better fix it real quick. There we go. All right, 4 4s are 16 plus 50 is 66. And we expected Lynn to earn an 86 because 6 times 4 is, oh, look what I did. I must have been typing it and I just reversed the units digit on the 2 of them. That's where the 4 went. All right, so 4 6s are 24, plus the 50 is 74, John. Sorry, I have been typing and typing and typing all this crap up to put together, because I didn't want to use my little handwritten notes anymore, so I've been trying to type everything up, and I just didn't do the math right. Let's see, 4 to 24, 74, okay. So let's ignore the Lynn observation for now, so I can just keep on going. I'll just fix it in my notes later. Let's ignore the Lynn observation. Now, so we expected them, and that's going to be the line. The line is what we expected, all right? But there's a stochastic error term. As a matter of fact, that's not what happened. Pat earned a higher grade than we expected. How much higher? 10 points. I'm going to have to fix the next one because I messed up the math, remember. And Chris earned also, let's see, Chris earned a lower grade than expected, which really sucks for Chris. And let me switch this E over here. Let's see, so I have 66, 60, 17. All right. They earned 17 points lower than they were expecting, or than the regression said they would have earned. So people don't get, even if we have the right regression, and we never know that. We never know that. This is something you have to ask God about later, okay? But even with the right regression, there's still some variation, and that's what this is showing. This is showing the actual grade is the dot wherever I put it, like up here or down here. The expected grade is the green line. And so then what you end up with, the difference between what was expected and what actually happened, is the stochastic error term. And again, that should add to 0. Do I have a graph for that? I thought I did. No, I don't. Okay. Then let's see. Next thing I want to show you. Yeah. What if we got more than one explanatory variable? And we almost always will have more than one explanatory variable. So I've been typing on these notes for days, and I've got 3 chapters done. And there are 12 or 15, something like that. So anyway, I can't type anymore. I'm going to kill someone. I'm just going to go do a video and get a couple of these videos out of the way, so I feel like I'm making some progress rather than having to wait to get this done. All right, what if we got more than one explanatory variable? What does the notation look like? Well, I'm glad I asked that question. Let's see. Y sub I is equal to beta sub 0 plus beta sub 1 x sub 1 I plus beta sub 2 x sub 2 I plus beta sub n, actually it should be a lowercase n. Well, it doesn't really matter, but I believe in the book it's lowercase. And x sub n I. So what you start doing is you just say, okay, well, beta sub 1 is associated with x sub 1. Beta sub 2 is associated with x sub 2. This could be, for example, grade, hours of study, and how much sleep did you get the night before, all right? And on that last one there, it could be, what was your SAT score coming into TCU? Because what I'm going to assume is that an hour of study for every individual is not equally efficient. That, for example, you might think, well, somebody who isn't a very good student, an hour of study is spending a lot of time checking Facebook. And so, as a consequence, we might need another variable in there. So all kinds of other explanatory variables. That's how we're going to do it, right? And again, just to introduce you to it, at this stage, it's not really important to remember it carefully, although we're going to use it. Let's see. Okay. All right. That's all been about the real true regression that one day God is going to share with you. But we can't do that. We're going to have to estimate the relationship. We don't know the true relationship. We're going to have to estimate it, okay? And so we are going to have to try to pick out a subset of all of the grades ever earned by every student going back to Aristotle. All of the hours of study. We can't get there. We're just going to get a subset of it. We're going to get TCU intro micro students fall 2020. We've got that. So we only have an estimate of the actual relationship. We don't have the actual relationship, right? So that's the whole frickin' semester. Estimate the relationship. Estimate the relationship. We don't know what this is. Oh, I'm sorry. I left off the stochastic error term, didn't I? Plus E sub I, because there's always a stochastic error term. All right. So let me show you how we write the estimated equation, because we use slightly different letters to show that. And yeah, I just showing an example here again. What if you got, let me walk over here. What if you got, we're going to estimate it, so you got to collect data. So let's say you've got the data for exams, just the final, and hours of study for every student in all TCU intro micro classes. You would arrange them something like this. You'd have like student 1, student 2, student 3. You probably wouldn't have their name, because that would probably be information you weren't supposed to be keeping. Then their final exam grade and their hours of study. All right, so you plug all this into the computer. And then, these all go into the computer, and it would spit out its estimates for beta sub 0 and beta sub 1. And this is how you write that. Let's see, eraser. Here it is. My Schollmeyer eraser. Let's see, I'm trying this out. Blue, I'm going to use blue. All right. Grade is equal to beta sub 0 plus beta sub 1 hours plus stochastic error term. Now notice I didn't put hours sub 1 because I don't need to. I have a specific word for it, all right? If I had an x there, I probably wouldn't do a sub 1 either because there's only one x. But if you have specific names for the variables, you don't need to put sub 1, sub 2, sub 3 associated with the betas. But anyway, we'll get to that later. Just a passing reference there. And that was a bad beta. It's not much better. Okay. This is the actual relationship that only God knows, all right? You're going to estimate. And what you're going to estimate is going to look like this. You're going to put a hat over the things that are estimated. You don't know if that's the true beta or not. You don't know, you just estimated it. Why do you put a hat over it? Because you're proud of what you did. You did a lot of work estimating these things. You want to dress them up, make them look real nice when people come to look at your estimate. So you put a hat on it, all right? So remember that. When it has a hat over it, it means estimated. A hat over it means estimated. So anything that was estimated, you put a hat over it, right? Now, I have a choice to make here. I'm going to put a hat over the grade. And I'll tell you why here in just a second. When you... I want to do that part first. Yeah, okay. So, all right. So, why put a hat over the grade? All right. Now, again, we know that's an estimate. We don't know the real number. No, that's an estimate. We don't know the real number. Hours, we got the real numbers for. At least for this sample of students. These are the real numbers. They told us, we're assuming they didn't lie, we told us how many hours they studied. We had the right numbers for grade, too. Why did we put a hat over it? Because in this instance, I'm saying I'm only talking about the grades on the line. Grade is equal to beta sub 0 plus beta sub 1 hours. Hat, hat, hat. The ones on the line are an estimate, all right? They are what the student would have been expected to make had the relationship been 1-to-1 straight on with these beta sub 0, beta sub 1, right? If there had been no random variation, then this is the grade they would have earned. All right, so if I put a hat over it, I mean, oh, I only mean the y's, I only mean the dependent variables that were on the line. Because they weren't all on the line. The dots were here. Let me just put some dots on here. The actual observations were like this. Some of them might have coincidentally been on the line, but most of them are not going to be on the line, right? So those are grade without a hat, all right? Those are the actual grades. But the grades on the line are, well, this is what I would have estimated they would have earned. It's not an estimate in the same sense that beta sub 0 and beta sub 1 are, because you came up with those numbers out of nowhere. Well, we'll show you where you come up with them later. But it is like you're saying, from my estimated equation, from my beta sub 0 and beta sub 1, the student that studied 6 hours should have been right here on this line. So the hat means the points on the line. It is not the ones they actually earned. It is the grades you use to determine beta sub 0 and beta sub 1, but it's not their actual grades. It's the estimated, all right? Now, if and I'm introducing a new concept here going through this. Yeah, good. All right. Yeah, let's do this. Okay. When I was typing all this up, I could not find an easy way to put a hat over a variable. Well, especially when it was more than one letter. So what that equation should say at the top of that little chart there is grade with a hat over it is equal to 45 plus 5 times hours of study, all right? And so on the far right over there, and this time I just wrote out the equation to make it easier to see, is what they presumably would have earned. In fact, let me write this. On the far right is grade with a hat over it. If you study for 15 hours, then 5 times 15, which would be what, 60, 75? Yeah, it'd be 100, right? So we would have estimated you would have earned 100. That's grade with a hat over it. 25, 50 for the second person, 75 for the next one, and so on down there. That's what the line that we estimated, and these two numbers up here, that I just circled, 45 and the 5 are estimates. The grade should have a hat over it. I kind of put the hat to the right because I couldn't fit it. And this might be a good time to say, why don't my numbers have a hat over them? Why do I only put the hats over the betas? Because if it's a number, we know we estimated it, all right? We know we estimated it because we don't have the real numbers. So if you're actually putting a number in there, well, that must be your estimate because we don't have the real numbers because they cannot be had. That's why we're doing the estimates. So by default, 45 and 5 are assumed to be estimates. grade here is an estimated or a predicted grade. And again, on the far right, you see a column for each student showing what grade we would have expected them to make given the equation we estimated. And oh man, now you're probably thinking, see, like I said, I've been typing. I changed the example. Oh, I'm sorry about that. After I got done doing the math, I thought, I don't like 45 up there. I want to do 25 instead. So I'm sure that was very confusing. I changed that on my results, but I had not changed it at the top of the deal there. Maybe I should work more on the notes before I actually start doing the videos. All right. So on the far right are the grades with the hat over them. And then on the, let's see, left there under final exam, that's what they actually earned. All right. So notice that what they actually earned and what we estimated them to earn are not always the same thing, and surely they're not going to be. It's going to be a coincidence where we end up with the same one. Now, what are we going to call the difference between, let me erase this and start it over. Okay. Grade equal to beta sub 0 plus beta sub 1 hours. There's a stray I up there. Hat, sub I. Okay. So grade sub I is equal to this, right? As we've been trying to drive home here. What if I wrote just grade on the left? Am I allowed to do that? Well, I am, because I'm the instructor. Dun, 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 dun. The residual, all right? We can write just grade here. If we add to the equation, and this is very similar in some ways to the stochastic error term, but the stochastic error term is an amount of variation that occurs, and I hate to word it this way, but in nature, you know, that even if we had the true equation, there'd still be that much variation. This isn't that. This isn't quite as natural as that. This is just how far off we were. All right, this is just how far off that observation was, and I've got those data down here too. And yeah. All right, what I did was I took. Well, I've still got 45 all over the place. When I went back to make my tables, like I said, I didn't like the way the math worked out with the 45, so I changed it to 25, and then I also hadn't changed it down there either. Sorry about that. All right, but at least I caught it ahead of time this time. Now, check out on students 1 through 4, and then of course 400, their estimated versus their actual grade. I've repeated those down here. And notice that the estimated grade for student 1 was, what they actually earned was 2 lower than what we estimated. And for student 2, it was 5 lower. So you keep asking the question, how far off was the equation? Well, it was, the student earned 2 lower on number 1, 5 lower on number 2, 8 higher on number 3, and dead on number 4, and 14 higher, lucky son of a gun, on student number 400, all right? Those are residuals, and residuals are the actual number minus what you estimated it to be, okay? Those are going to turn out to be incredibly important. The difference between what your equation thought the grade was going to be versus what it actually was is going to turn out to be incredibly important, all right? Knowing that concept. Oh my God, check this out, I still got 45s everywhere down there, all right? And what happened was I had written up the notes before I decided I should put some tables in here. And then when I put the tables in, I changed the numbers, but not where I had typed it up, all right? So I'd change. I'll go back and fix all that, all right? So those are going to be incredibly important. How close are we to the end of this chapter? Pretty close, all right. Okay, so let me show you this then. And yeah. All right. So what we've got here so far is basically 3 different kinds of equations. And this residual thing is going to be huge. ironically, we don't want the residual to be huge, but its significance is very high. Not statistical significance, just how important it is. Let's go back to y's, all right? Y sub I, it's a heck of a lot easier to write, is equal to beta sub 0 plus beta sub 1 x sub I plus e sub I. Again, I'm not bothering with putting x sub 1 here because I only got one x. So I only really bother to do that. I only would really bother to do x sub 1 sub I if there was more than one x. But I don't have more than one x, so I'm not going to bother. This is the supposed true equation. The one that only God knows, right? Now I've got two versions of the estimated equation. Hat, hat. Estimated with y hat at the far left, all right? This is just the line that you estimated. So clearly, if we're only talking about points on the line for y, what grade would they have earned? Oh, well, everything that's on the line, all right? What grade would they have earned? Well, they would have earned exactly 25 plus 4 times, or whatever I did, 5 times the hours of study, whatever our parameters are here. So this one's just showing you where are the points on the line, where are the grades they would have actually earned. But if we're going to say, yeah, but what does their actual grade equal? Now we've got to add a residual, because the actual grade is going to vary from what we forecast the grade to be based on our regression. Let's see, estimated with just y as the dependent variable. Yeah, so these are the 3 ways we've got so far. We're pretty much, when we're talking about kind of the background, discussing what I believe the relationship is in reality is this, you might use this one. But honestly, we're mostly going to do this right here from here on out, because what's the class about? The class is about estimating these relationships. 27 minutes. And so we're going to spend most of our time with these two right here. Now, that's a good point I made right there. Something, and actually I think I said it earlier, but something you would never do is x with a hat over it. We're never going to have that. Because we're always going to use the actual data that we got for the independent variables. We're never going to talk about the forecast independent variable, the forecast number of hours. We could talk about the forecast number of hours, but we'd need a whole new regression. We wouldn't do it this way. So we would never talk about a hat over the x. What else we got here? I think I'm about done. We never try to, yeah, okay. All right, I just want to show you this, and then that'll be chapter 1. Oh, I cannot wait for the next concept here. I'm looking forward to that. All right, so let me show you this. Really good graph in the book. Here we go. Really good graph in the book. It's figure 1.3, where he shows not only the true line, that's the solid black line. And of course we don't know that. We don't know what the true black line is. Remember, one day, jot this down as something to ask God about, right? And the difference between each dot, now the dots are the actual, when we're assuming we have accurate data here, the dots are the actual y's associated with the actual x's. Let's think again about x as being the hours of study and y as being the grade. The dots are the actual hours of study and the actual grades. Well, notice the dots are not on the solid black line, right? And that's right, they're not on the solid black line because, remember, in even the true relationship, even the true one, has some random elements, all right? So you don't always get, did I stand right in front of it when I did that? Has some random elements as well. So even the true equation is not going to end up with all the points on it, all right? But there's a difference between that and the dashed line. The dashed line is the result of you collecting some data on student hours of study and grades, plugging it in the computer, and seeing what the computer gives you, all right? And so there too, the black dots are not going to be on the dashed line, but for a different reason, all right? This isn't because of the fact that the dashed line is really the true relationship, but there's an underlying random factor nevertheless, it's because it just missed, all right? There's no better way to think about it as that's just what was left over after you ran your regression. Don't think that it's more significant. And I'm saying all this because I remember from when I took these classes, they made a big deal out of making sure people did not think of this and this as the same thing, but one's an estimate of the other. It's not really. It's not really an estimate of that. So, I mean, that may not have crossed your mind, but nevertheless. So the difference between the dots and the dashed line is this. The difference between the dots and the solid line, oops, is this. And here's where we're going to get into the next chapter. And this is just really, really interesting. Here, let me show you like this. No. Let me do it this way. All right. Let's finish off with this here in chapter 1. Okay. You've collected all these data, all right? There's your hours of study. Here's your grades. Essentially, what econometrics does, well, actually what regression analysis does, is it tries to fit a line in there. And where do you want that line? I mean, here, here, here. How are you going to measure where you want the line? You want the gap between the line that you estimate, which would be the dashed line in the thing I just showed you from the book, the gap between the line you estimate and those dots to be as small as possible. You want to minimize those residuals. You want the, I mean, look, if I'm way up here, my gosh, all the dots are a long way away from the line. That kind of sucks. And as you can see, it probably doesn't really represent the relationship. You want to minimize the gap between the dots and the line, and that is everything. All right? That is what we're going to try to do and what we will be laying out in chapter 2. Yes. May the force be with you.